Okay, let's begin. So today I just want to make sure that you know how to digest the rules that we went over last time about exponentials and logarithms, because we're going to be messing around with these functions during this class. I want to make sure that we are all aware of how they work. So let's spend some time going through this. Okay, simplified. How is that simplified? What is that? Yeah?
-2.
-2? Why do you say it's -2? How? Huh?
Because I think the E and the L cancel out.
What rule are you thinking about here?
I don't know what it's called.
Huh?
I don't know what it's called.
Okay, but tell me what the rule says.
When it's E and L, I think they are inverse of each other or something. They
Yeah.
cancel out.
So if you have e to the ln of something, then the e and ln cancel out and you just get something, right? That was a rule. So that is correct, that is a rule. That rule does not apply here though. Why? What's off? Why can't I use that? Yeah.
There's a negative.
Because there's a negative sign. In the rule, is there something in front of the ln? Nothing in front of the ln. Here we have something in front of the ln. The rule does not apply. Which means, first important fact of today, and this is just something that's going to be true in general. The rules and formulas I give you, these are your templates, right? You need them to fit exactly on top of the problem that you're looking at before you can apply them. What you're looking at must fit them exactly. Otherwise, you'll get into trouble. So this does not fit that rule exactly because there's something in front of the ln, and in the rule, there's nothing in front of the ln. So, what do we do? There's some way to remedy that? Yeah?
Is the answer 1/2?
How do you get there?
Because it's you take the reciprocal and then you cancel out the E and L and then you cancel.
So it's a negative power, so you just take the reciprocal like this.
And then
Right, you can do that. And now the e and the ln right beside each other, just like they are in the rule. Now the 2 is kind of like this bold x in the rule. So at this point, I can cancel them. And so that's 1/2. So 1/2 is the correct answer, not -2. Right? And why could I do that? Well, the rule we are applying here was the rule that says if I have a negative power, it's just 1 over the base to the positive power. And I can apply this rule because I know e to the ln of something is equal to the thing. Right? So every step you make, it's because there's a rule that says you can do it. By the way, there are multiple ways you can actually do this by just looking at different rules at different times. So you could also have e to the minus ln2, and you know you want to cancel the e and the ln, but you realize that that negative sign is in front, so what you can do is you can actually move it. Notice that we have a rule that says if there's something multiplying in front, I can move it up as a power, right? So there's a -1 in front technically, so I can actually rewrite this as e to the ln of 2 to the minus 1. Why can I do that? Because there's a rule that says if there's something in front of a logarithm, I can move that thing up and put it as the power of the thing being logged. Right? So I can take something from in front and put it up here. Right? I'm allowed to do this. So there's a minus sign in there, and I realize I can't apply a rule because that negative sign is in the way. I can literally move it out of the way once there's a log. Now what you realize is the ln and the e are right beside each other. They would cancel. And so now you end up with 2 to the minus 1, or 1/2. So you get a half that way. Or, many ways to do this. Let's look at another way. Another thing I could have done was, I'd actually factor off that minus 1. I could look at this as e to the ln of 2 times minus 1. Why could I do that? Well, there was a rule that says that. So two things are multiplying. I can think of that as something to a power raised to a power. So here I have minus 1 times ln of 2. I can think of that as just e raised to the ln of 2 and raise that to the minus 1. Now on the inside of the parentheses, e and the ln will cancel because that fits the rule. And so inside the parentheses, I would have the 2. Then 2 to the minus 1 is equal to 1/2. And why is that equal to 1/2? Because there's a rule that says x to the minus 8 is equal to 1 over x to the 8. And that brings me here. The rule that I applied here was that e to the ln of anything is just the thing. And the rule that I applied here was that x to the minus a is 1 over x to the a. So here's the moral of the story. One, there are multiple ways to skin a cat. Just make sure that you're doing it legally. Right? Legally skin the cat. You can legally skin the cat in multiple ways. Now, what constitutes legal? Legal means there's a very specific rule that Jhevon wrote down in that class or a previous class that says I'm allowed to go from this step to that step. Okay? Now, if there is no such rule that says you can do that manipulation, you are wrong. As long as you follow the rules, you'll always be right. Right? You're literally just thinking of every rule I give you as a template. It just tells you what positions you can move things in. Like pieces on a chessboard, the piece moves this way. You can't just move it any way you want. It has to follow a certain rule. It has to follow a certain path. And so you have to make sure things look a certain way before you can make certain moves. And you can do that and not even really understand what you're writing down, what any of it means. You're just like, well, I know this is a rule that says I can do that, you do that. And you're an A student. You're an A student just like that, by just moving things around according to some template. Right? At this level, that's all you need to do to be good at math. You don't really have to understand anything, paradoxically. But yeah, make sure that every time, and I'm not always going to do this because that will take too much time. I'm just illustrating it with this first problem for you to see the thought process here, right? So sometimes I won't always write this, I might just write this, but it's important for you to realize that when you see me writing down an example, or you're practicing, or you're doing homework, or you're studying for a quiz or a test or something like that, make sure that for every step you take, you know the reason for that step. I'm allowed to do this because of this rule. I'm allowed to do that because of that rule. I'm allowed to everything, there has to be a reason. Nothing is random. You don't do anything because you feel like it. Okay, I think I saw Jhevon do something like that one time. No, not a valid reason to do anything, right? That's how you get in trouble, right? If you're sitting in a test and you're like, I saw one like this in class, what did Jhevon do? Yeah, it was in the second week, in the first 10 minutes of it. Your mind, you're never going to remember things like that, right? How you are going to train yourself is to that every time I give you a list of rules, you're going to copy it down in a separate location on one sheet. It's going to be your formula sheet. Whenever you're practicing or doing homework, you look to the formula sheet. If you're in one step, you want to move to another step, is there a rule on this formula sheet that allows me to move to the other step? When you find that rule, you make it the step according to the rule. Then what's the next step? Is there a rule that allows me to do that? Right? And Yeah, I mean, is that, I mean, it probably sounds like that would be time consuming and painful, and you're right, it is, it's gonna be really annoying, but the upshot is, eventually, you won't need to do that anymore. Eventually, after looking at your formula sheet like 50 times, you're gonna start remembering, and it's gonna become natural. And then you're gonna be able to do math based on feelings, right? It's gonna just feel natural for you to do it. It's kind of like how when you're talking, you're not thinking of grammar rules. What's the subject verb agreement? You don't think that, but you don't remember. Once upon a time when you were a little kid and you didn't know how to speak, you had to know subject verb, the quick brown fox jumped over the lazy dog. You had to learn this at some point, right? Math is the same way. You have to learn it the proper way. Make sure the rules are your guide, and that's how you kind of wean yourself into it. So in the beginning, it's going to be a very painstaking process, but it is worth it. You can get over that hump. You're an A student. That's all it's going to take. So just make sure you're knowing why you're making every step, every single time. Always have the rules beside you, and you want to internalize them. And once you can do that, you'll be fine. And you'll be able to do things multiple ways. You don't have to remember exactly how Jhevon did that in the fourth lecture, in the first half of the lecture. You don't need to know that. You can do things multiple ways and you'll always get to the right answer because the rules are your guide and it's now internal, it's a part of you. Right? So if you don't want to end up in that situation where some people are like, I think I did well on that test, and they get their test back and they did horribly, you know, or man, that test was tough, and then you get the test back and you actually did great, and your friends look at you like, I thought you said that, right? Because for some people it's just like luck, it's a shot in the dark. The test was hard. No, it doesn't matter what the test is. Whatever it is, you just need to follow certain rules, and that way you know you did the right thing without the shadow of a doubt. There's no ambiguity. There's no guesswork. There's no, ooh, how do I do? I don't know. It's a toss-up. No. If it's a toss-up, it's because you don't know the rules. Right? You need to do things in such a way you know they're right. It's the right route to make. And you can do things multiple ways. You can get creative, and you'd still end up with the right place. But, so that very important thought. Okay. Now let's continue. Got a lot of mileage out of that first problem. What about this one? Okay, go, simplify, what do we do?
Can
Yeah.
I cross out the E and ln?
Right, so here the E and the ln, I assume you mean this one, they're right beside each other, just like in the rule, right? This is like the x from the rule that I just wrote down there. These would cancel, and you'd be left with, well, ln of e cubed. Then what?
Cancel the ln with E.
Right, there's another rule, right? There's a rule that says when you have a log, that, then the log, if you plug an exponential into the log, they also cancel. The ln version of this is if you have ln of e to anything, just get the thing. Right? So that actually directly follows from a rule. So the e and ln cancel again, and now you're yourself with 3. 3 is the answer. Or notice if I have e to the ln of e to the 3, I could have applied this rule first, just apply it in the power. And then I would have e to the ln, that's going to be 3. And then I apply, well, the other rule that I erased. The ln version is e to the ln. Then I apply that rule, which means that these two are going to cancel. And so I would get 3 again. So you're going to get the right answer as long as you follow the rules. So that actually simplifies to 3. That's a very fancy way of writing 3. Okay, what about this one? E to the ln of x squared minus 5 ln of y.
You could move the 5 to the
Okay.
y,
Mm-hmm.
and then
So that would be e to the ln of x squared minus ln of y to the 5th.
you could divide those because of the subtraction rule.
Right, so if you have x to one power minus another power, it means that x to the a over x to the b. Right, a subtraction of the power means a division in the base. So this is e to the ln of x squared divided by e to the ln of y to the 5th. Then,
You could cancel out the e and ln, and you're left with x squared over y to the 5th.
right. This one you could also do in multiple ways, just another way you could have done it, yeah, you could have done it like this, ln of y to the 5th. And then there's a rule that says you can combine a subtraction of logs. Log of something minus log of something else gives you what? Like in the power, what does that become? You have a rule like that? ln of a minus ln of b is
A divided by b.
ln of a divided by b. So this you could think of as x squared divided by y to the 5th. Then that would cancel. And we again get x squared divided by y to the 5th. Apply that rule. Then even done something else. Could have thought of it as addition. So let's say you can think of this as ln of x squared plus a minus ln y to the 5th. You could think of that as multiplication in the base times e to the minus ln of y to the 5th. And you can bring this negative sign up. That's e to the ln of x squared times e to the ln of y to the minus 5. That cancels that. You get x squared times y to the minus 5, and that is x squared over y to the 5th. As long as you follow the rules and you're applying them correctly at the right point, you'll get to the right answer. Now, I don't care which one of how you get there, just as long as you get there in a valid way. And if I ever write down multiple ways, that you don't have to learn everything, right? Whichever way stuck out to you first, whichever way you saw first, just learn it that way, forget the other ways. So if you notice this division first, just do it that way. If you notice, oh, I could have combined the logs first, do it that way. But just make sure whatever you're doing, there's a valid reason for why you're doing it. How would you expand that? To expand it as a sum of logs, just make it a bunch of simpler things.
You could do ln parentheses, and then of x squared minus 1 over x times x plus 3 squared, and then put a half.
Okay? Then? Right, so if you have ln of a divided by b, you can split that up into ln of a minus ln of b. Any issues will applying that here?
To your exponent,
The exponent is a
move
problem,
it to the
right?
front.
So this here, notice that there's nothing here, right? So yeah, you're seeing the right thing, but you have to realize, is there anything in the way of me applying that? Does it fit exactly on top of this as a template? The answer is no, because of that guy. So if this is an issue, as you said, you can get rid of it, you can move it, right? According to the rules, right? So we can actually, if you want to apply this, you need to get rid of that half. We can get rid of that half by moving it down in front according to the logarithms. Now we can do what we wanted to do. We can split the logs into a subtraction. Now that isn't exactly right. What's wrong? Yeah. Right, the 1/2 has to be distributed, or you can just realize that, oh, there are parentheses here, right? So it's 1/2 times, when you're splitting up the log, the half has to be distributed. So either put the half on both, or write parentheses to indicate that it needs to be applied to both. Okay. But let's leave the half out there in front. What else can we do? Can we split these and expand this any further? What else can we do? Yeah.
You can do plus ln x,
Where?
so parentheses in front of the second ln,
Okay.
and then do plus ln x.
So this is 1/2 ln of x squared minus 1 minus, you want a parentheses, ln x?
Or minus x squared, not ln, minus x plus 3 cubed. The other way around.
You need the ln in front of the x plus 3, right?
Yeah.
Right, so if you're putting the minus, it means you've already, technically it's a plus, right?
Yes.
Because it's a multiplication, but the negative sign distributes, and so you can turn that into a minus. Okay. Now what? Yeah. Right, 3 can come down. Want things to be as simple as possible. Expand and simplify. So we have ln of x squared minus 1 minus ln of x minus 3 ln of x plus 3. Anything else? Yeah.
You could do the same thing with x squared minus 1 and do it x minus 1 and x plus 1.
Right, that's the difference of squares. That's x minus 1 times x plus 1. Should almost be a knee-jerk reaction at this point where there is the x squared minus 1. So you have ln of a product, you can split that as a sum. So this is 1/2 times ln of x minus 1 plus ln of x plus 1 minus ln of x minus 3 ln of x plus 3. And that's pretty much as simple as you can get. Now, it wasn't suggested here, but a couple of my other classes suggested this, so let me make sure you know. ln's do not distribute across sums, right? So you can't actually say ln x minus ln 1. Like that's not, there's no rule that says you can do that, right? So logs do not distribute, right? So that should be something. If you have ln of, say, a plus b, it is not ln of a plus ln of b, right? Remember, when you're adding logs, it turns into a multiplication. This is equal to a multiplication. It's not equal to that. So logs do not distribute. So if any of you were thinking that for a second, no, squash that thought. Doesn't work with logs. So that's as simple as you can get it. Why would you want to do that? Expanding logs is useful. How do you know when you want to expand the log? Well, when you're doing calculus. So what do I mean by calculus? Well, I haven't even told you what calculus is yet, but we're going to be doing things like taking limits, derivatives, and integral. Now, if the problem is something like that, where I say, oh, differentiate or find the derivative of this logarithm, what you want to do first is expand the logarithm. Whenever you want to do something with calculus, expanding into simpler, smaller logs is going to make your life easier. So just know that expanding a log is something you're going to want to do whenever your goal is to apply some rule of calculus. Which next week we'll find out what that is. Don't worry about it yet. But just know, okay, if I want to do some calculus, I need to expand the logs. 3. Now we're going to look at combining the logs, which this is important for a different reason, but it's also an important skill to know. How do we go about combining?
Could divide the first two terms.
Right, we have log of something minus log of something else. Right, so that's log of the division, x divided by x cubed.
And then you can turn the addition sign into multiplication. So you could multiply x over x cubed times x to the 4th.
Well, x to the 4th.
Yeah, because you
Which
remove the
means
4.
you first have to move the 4
Yeah.
before you combine the. Right, because to add the logs, we don't have anything in front of it. Right, so it's ln of a plus ln of b. There's nothing in front, so that becomes ln of ab. So if I move that up, I have log to the base 2 of x over x cubed plus log to the base 2 of x to the 4th, and then I can multiply. So it just becomes x over x cubed times x to the 4th. And now I start simplifying. This goes into that 2 times, that goes into that 2 times. So I have log to the base 2 of x squared, or I can write it as 2 log to the base 2 of x. Notice another thing you could have done here. You could have brought the 3 down according to a log rule. So that's log to the base 2 of x minus 3 log to the base 2 of x plus 4 log to the base 2 of x. And just notice now that you have like terms. Okay. You have 1 apple minus 3 apples plus 4 apples. So that would actually leave you with 2 apples. Could have done it that way as well. Now, when is combining logs useful? When your goal is pretty much algebraic, as in something like solving an equation. So if I gave you an equation with a logarithm in it and I say solve for x, chances are you're going to want to combine any separated logarithms. If I give you a log function and say, hey, find the derivative, do some calculus operation here, then what you're going to want to do is you'll want to expand the logarithms. So whenever you want to do calculus, expand the logarithms. Whenever you want to do algebra, contract the logarithms. Right? These are some general principles here. So you should know both how to combine logs together and expand them and separate them apart. Because in different situations, one might be more convenient than the other. Speaking of solving equations, let's do some solving equations. Solve for x, a. Okay, go. Yeah,
X would be the natural log of 12.
how do you?
Because you can take the natural log of both sides, so that the natural log would be cancelled.
You can plug both sides into a logarithm. So you can plug in the left side into a logarithm and plug in the right side into a logarithm. We usually call this, like, I'd say log both sides. Right? Because if two things are equal, then their logarithms are equal. Log is a one-to-one function. So if the inputs are the same, the outputs will automatically be the same as well. So I can actually throw both into the logarithm. That allows me to cancel here. So I call this log both sides. So if I'm working something out, I say, oh, just log both sides. This is what I mean, right? And then just get x equals ln of 12 would be the answer. Now sometimes I might be lazy, I might not even write this line, I might just write right on top of it, oh, just put an ln. And that's what I mean, I'll just log both of them. And you'll get here. Note one thing you can also notice is also follows directly from law 1. Remember law 1 was the guy that said, well, if I have log to the base a of b equals c, then that means a raised to the c equals b. Or in the ln version, that means if I have ln of b equals c, then it means e to the c equals b. Which means here I started out with like an e to the c equals b. So the 12 is like my b, the x is like my c. So how do I solve for c? Well, it's going to be ln of the b, which is ln of the 12. It's harder to see this though when things start getting more complicated, so probably what I would prefer that you do, it's easier psychologically speaking, is just that realize logs and exponentials are inverses of each other. We mentioned that before. They undo each other. Kind of like how addition is the opposite of subtraction, multiplication is the opposite of division. Logs are the opposites of exponentials, and exponentials are the opposite of logs. So if I have an exponential and I want to get rid of it to solve for something, I use a log to get rid of the exponential. So logs will get rid of the exponentials, and exponentials will get rid of logs. So you can use one to cancel the other when it comes to an equation. Which leads us into B, where we have ln of x equals 9. So
You could e both sides.
you e both sides, right? You kind of plug both into an e, right? E both sides. Which, that is not correct to say grammatically or otherwise, it's just kind of a cue. What does it mean to e both sides? Exponentiate both sides. Right? So in words, these phrases aren't technically correct, but it's just a cue for you to know what to do. So I can plug both into an exponential. Why? Because exponentials will cancel logs. In the same way that logs will cancel exponentials. Right? I can use one to kill the other one. Right? So if I have an ln, I don't want an ln. What do? Use an e to kill it. If I have an e, I don't want the e. Use an ln to kill it. Right? So you can exponentiate both sides, and you immediately would end up with x equals e to the 9. By the way, this also follows directly from law 1. It's just that I started on the other side of the equation, went to this side, or went from here to there. But the idea You can use logs to kill exponentials, you can use exponentials to kill logs. That's something that you want to think about. So you have an exponential, you can log both sides, just use the same base. ln, I use ln specifically because ln has the base e. And this is a base e. And since ln has base e, I use an exponential with base e. Okay, we saw that one.
Both sides.
Log both sides. So on the left side, ln will kill the e. So I'll be left with 5 minus 3x equals ln 4.
You could subtract 5 and then divide by negative 3.
Don't want the negative, I can multiply by minus 1 over minus 1. And I can get x is equal to 5 minus ln 4. Common error here that I don't want anyone to fall into. Just in case, notice that you cannot combine these two. The 4 is inside the ln, while the 5 is outside, right? The 4 is in the ln. Right, the ln is operating on the 4, the 5 is something separate. So every now and then I'll see students try to add something, or they can try to like divide something. You can't divide something from outside of an ln inside, or you can't add something from outside of an ln inside. What's inside the ln stays in there, it's protected. Right? The only way to penetrate the ln is to use an exponential. So don't think that you can combine things here. So it's just ln of 4. The 5 is separate. Yeah?
Add ln x to both sides first. And then you can use the one of the log rules to combine it to be 2x squared plus x on the inside.
Right, so okay, then
You can exponentiate it.
that gets rid of the log. So now I have 2x squared plus x equals e squared. Then,
Well, to solve for x, you could subtract e squared from both sides and then factor.
factor. So it's
I don't know how to factor that.
it's a quadratic, right? So that's what you should notice. Hey, this is a quadratic. I know that form. Factoring does seem like it would be annoying. Any other options? Quadratic formula. Right, so you can also remember the quadratic formula as an option. So quadratic formula says if you have ax squared plus bx plus c equals 0, then your x is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. So here your a is 2, your b is 1, your c is minus e squared. And I can apply the quadratic formula. So this means my x is minus b plus or minus the square root b squared minus 4 times a times c, which is make this a plus, all over 2a. So this is illustrating what I mentioned earlier. When it comes to solving an equation, combining logs is usually going to make your life easier. So we had logs separated here. Gather all the logs, combine them into one log, and then you exponentiate to get rid of it. This will give you an equation where hopefully there are no logs present, and you can use some previously learned technique to actually figure it out. E would be the same idea here. I have some separate logs. First thing I'd want to do is combine them. Now what?
You could do 10, like the base is
Right.
10, so you could,
Base is 10. Can 10 both
Yeah,
sides?
and then cross it
Raise both
out.
sides to 10. This will cancel. So you would get x squared minus 3x equals 10. Which that's a quadratic, so I bring everything to one side. Now what?
could factor. X minus 5x was 2.
So you get x equals 5 or x equals minus 2. Is that the answer?
You have to check. Right?
Right. You have to check, right? Because logs aren't like exponentials. Logs don't work everywhere. So, for example, notice that we saw this last time. What was the graph of what a log was? Y equals log to the base a of x. It looks like that. And I want you to notice that the domain here is anything that's strictly greater than 0. You can't have the log of 0, you also can't have the log of anything negative. Now if my x is negative 2, you will notice that if I plug it right here, I get log of negative 2. So this is rejected. Can't log a negative. And so because you would end up with log of negative 2 plus log of negative 5 equals 1, which makes no sense. You can plug in 5 though. If your x equals 5, you'll notice that you'd have log of 5 plus, plug in a 5 here, you'd have log of 2. You can combine that into log of 5 times 2. That's just log of 10. Now the base is 10, means that's 1. And 1 is the answer. So that's our answer. Which, by the way, strictly speaking, we should have checked both answers here. There's a plus answer and a minus answer. The minus answer puts us in dangerous territory. We have to make sure that if I plug in a minus here, if I take that, plug in that answer here, and I multiply that by 2, I have to make sure that I actually get something less than 1. And I don't think that's less than 1. The minus might not actually be the answer, so we should check that. This one's not exactly clear without a calculator, but you know that the negative won't work. Because this square root of this here is definitely bigger than 16. So that's definitely going to be negative, so the negative won't work. Any questions on that? Let's see what we're doing here. Okay, last one, 2 to the x squared plus 1 equals 5. How do we solve that? Yeah.
Log base 2.
Right, so the base is 2, log base 2, log base 2. And so that cancels here, and I have x squared plus 1 equals log base 2 of 5. You can solve for x. X squared is equal to log base 2 of 5 minus 1. And so your x is equal to plus or minus the radical log base 2 of 5 minus 1. Now does that actually make sense? But can we actually log that? Well, here's one thing you can notice. Another thing you notice about logs is that it's also increasing. So when the x value gets larger, the log gets larger. So in particular, this is bigger than log base 2 of 4, right? So if I plug it in a 4, I'll get a smaller number than if I plugged in a 5, right? So the log of 5 is actually larger than the log of 4. But what is the log of 4?
2.
That's actually 2. Log base 2 of 4 is actually 2. So this means that log base 2 of 5 minus 1 is actually something that's bigger than 2 minus 1. So that's bigger than 1, so that's positive, which means taking a square root actually makes sense. So this answer actually makes sense. And that's that. So, moral of the story, rules are templates. Every time you do something, there's a rule that you're thinking of while you're doing it. If you can't think of a rule, chances are you're wrong. And you need to study harder. So, this is all going to be useful later, but we'll pick up next class with, we'll actually start calculus next class. And of course, next class, remember we have a quiz every week, so you'll have a quiz on this stuff. Go home and practice. Have a good weekend.